Okay, where's that robot? This robot's here. What's its problem? Oh, it's navigating. Oh yes, you can see it. My map got really whacked on this side, so I just designated some waypoints on the left-hand side here. And you can see the path planning, the green line is path planning move base, telling the robot where to go. There's one little arrow out there where I directed the goal within RViz. So this is a simulated floorbot challenge where, since one side of the room is whacked, I'm just going back and forth on the other side. But regardless, this is something we do at our SV-ROS meetups. It's a combination SV-ROS and HBRC SIG Special Interest Group. Our special interest is ROS. We meet the penultimate Wednesdays at Nexus, Maker Nexus, thank you, in Santa Clara. Everybody's on the mailing list? Yes? Be on the mailing list. Okay. So here you see the robot. He's going to make it to this point eventually. I'll bring up my G-mapping terminal here. There it goes. And you see him getting a new plan, getting a new plan, getting a new plan. And when he gets oriented right, you'll see the goal reached.
Did you remember to save your local cost map?
I remembered to save the map before I killed G-mapping. That is important. Also, this is RViz, ROS Visualizer. And look how nice this is for like visualizing things. And again, this is the Nito bot vac here. But there you see the LiDAR scans. It's all three-dimensional and stuff. Pretty cool, huh? Okay, so let's do this. This is my floor bot. Let's see here. That's not it. Okay, here's my floor bot routine. I'm going to kill it. Boom. So next time it gets to the waypoint, it'll actually stop. And I've got, where's my robot? There he is. And he's going to get to this waypoint. He's going to stop. And I'm going to send him back to this corner over here where you select 2D nav goal, point, press, and drag, and the little robot will be oriented in the direction that you've placed. Oh, here's something cool. This is a ROS tool. Mike Ferguson, nice to see you. Incidentally, Mike Ferguson wrote this code originally in 2010, and then Ralph, doing the presentation this evening, redid it with launch files. We stand on the shoulders of giants, folks. So here comes ROS topic, echo, and I think it's just command velocity here. Yeah, here you can actually see the messages being sent to the robot. X, Y, and Z coordinate. The X and Y is the X and Y planar of the map, and then the Z is the angular position. Got one other thing. This is Loco Joe, part of the Loco series. I've basically taken the bot vac and I bolted a TurtleBot superstructure on it. And the concept is three things: general delivery, telepresence, and AI. I've got the raspy audio in there, so it's got a little voice synthesizer. And I do believe Turtle has made it back to his goal there. Yes, thank you. One more trick. Hold the microphone over here. Laureen inspired me. Aww. Okay. That was on Turtle. Let's do the Turtle. Sorry. Yeah, that's good. Okay, now the other one. Now Joe.
Now is the time.
Oh, that's not right.
Who's there? Who's there?
Oh, sorry.
Another joke.
Welcome to deliver.
All right. Timing's off. Yeah.
It's funnier this way. I think I might make a script for this or something.
Could help.
We're driving Ross Node today.
Part 2.
Here's the big punchline.
Like your own material.
Painful.
Part 2D2.
Wait, there's more.
On what?
Either way.
Painful.
Ha 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 ha.
You're easily
Ha ha
amused.
ha 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 ha.
Thank you very much.
Ken, how are
Yes.
you hooking up the speakers?
I'm sorry, what?
How are you hooking up the speakers?
This is a hat called Raspy Audio.
Yeah, but I mean your...
It's a Raspberry Pi hat.
It's a Raspberry Pi hat. Okay.
Yeah, the speakers are on the Raspy Audio.
Okay.
And it has a microphone too.
Okay.
I think it's like $30 or something. Raspy Audio. I'll put a link on the mailing list. Everybody's on the mailing list. Yes, Bill.
Maker Nexus is Northern Sunnyvale, not Santa Clara.
It's just right down the street.
Sunnyvale, Northern Sunnyvale. Maker Nexus, where we have our HBRC SIG / SV Ross meetup, 7 p.m. penultimate Wednesdays, is in Sunnyvale. Thank you, Bill. All right. And we'll mention it on the mailing list. Thank you.
All right, thanks, Camp.
It's awesome.
It's actually a table. They're on the table. Okay, so this is the same robot that I've been playing with for the last year, the one with which we went to China to win some Chinese money. But right now I'm playing with fiducials again, and I was trying to set up 2 cameras and see if it can work with both of them, detecting the fiducial. So let's see if we can make it work here. So what it should do is so I will start it somewhere here, and it should drive my way and then see the fiducial on this camera, and then it should turn and come towards me while watching the fiducial on this camera. So let's start something. Okay, amazing, it worked. So this is using the ROS package AR track over, and that package can work actually with 3D cameras as well, and these are 3D cameras. Right now I'm just taking the RGB image from each of them, but I guess the next thing I will try to use actually 3D output and see if that makes it any better. Yeah, that's it.
What kind of processor do you have in there?
The processor for processing the images is Intel NUC, I think, Celeron based. Something with 4 cores. Not incredibly powerful, but apparently that's enough.
What was the name of that ROS package to recognize the tags?
AR Drac Alvar, I think.
AR track
Yeah.
April tags also.
Maybe.
What sensor are you using?
The sensor is Intel,
The real sense?
yes, RealSense D435, I think, something like that.
Okay, very good.
Yep.
Thank you. Yes, come on up.
Yeah. So people have mentioned the special interest group involved with ROS and talked a little bit about ROS as sort of this platform for building intelligent robots much more easily.
Microphone time. Can people hear me better now?
Yes.
Excellent. So people talked about the special interest group for ROS. It was last week. I went there. I really enjoyed it. I was somewhat inspired to ask the question of what's the sort of lowest cost, lowest hassle entry point you could make that unlocks that ecosystem of programs. And so I started working on this, which was basically me asking the question of what if instead of running the program on the robot, you run everything you can on your computer or in the cloud. So this is built around an ESP microcontroller, which has Wi-Fi access. And so that means that the code can be running on a computer, but you can still get sort of the abilities that you have from ROS. So in this case, I have a joystick connected to the computer going through sort of a series of programs, and I didn't have to do any of the work of reading a joystick driver or doing anything with that. This is sort of the very first demonstration of it moving around. There's nothing autonomous happening here yet, but hopefully next month we'll be back with sort of taking more advantage of the ROS ecosystem. So I wanted to just show off a little bit what that looked like, and generally the sort of vision here is to be useful as a platform for education at various levels, to have something that's cheap enough you can distribute it to a classroom. So if there are people who do that or have experience with that, I'd love to talk with you as well.
Does it require the ESP32 or does it work on the 8266?
So this is an 8266 because that was what was sitting in my toolbox. I think it certainly works fine. There's no Python or ROS running on board. It's just relaying data remotely, which can be very easy. The plan is to go to an ESP32 so you can get a camera on board and do some of the tag tracking and other things that we saw with sort of that behavior. And then there's also of course, work to be done with just figuring out what the sort of setup procedure is and what the ways of handling Wi-Fi reliability are to really get high performance out of something that's at times a questionable link. So that's sort of the next steps for me, is upgrading to the ESP32 and figuring out how to get some of that more autonomy running.
This looks like a great robot to run the TableBot challenge. That way.
Yeah, we'll see it next month probably.
What's the latency?
So latency is fast. The problem is packet loss. So basically, it's a couple milliseconds. Like radio waves are really, really fast. But the important thing is going to be moving from TCP to UDP, because in most cases, if a connection drops, I want to just keep going anyway, rather than wait around for the next connection to come through. So latency is important. It should be a couple milliseconds, which, let's be honest, all the computer vision algorithms people are running are more processing time than that anyway. It's just a question of handling failures gracefully.
Very cool.
Thank you.
So everybody probably knows the project that I'm working on, the 3D printed Curiosity-like, the SOPI rover. I had it here last month. It was in pieces. I've managed to reconstruct it. I've learned a few things. One is that probably the biggest thing is that I've replaced the longer axles, the longer shafts that were the 3D printed, the nylon. I went to metal with those because not long after this, I got a. I'm now one of the roboticists in residence at Circuit Launch over in Oakland, which means I have access to their shop, which means a drill press. So I was able to cut metal shafts again. So for the longer ones, kind of the biggest change is the big two weight-bearing shafts. Those are, I went back to metal for those. It was a nice experiment. It's actually working pretty well on the shorter ones, on the drive axles. Those are still in place. Those are holding up. They're bearing the weight of the robot. They're not deflecting too much. They seem to be fine. So that's kind of like my key takeaway is that you can use interesting material. You can use different materials, reinforced materials, 3D printed for structural parts. You just have to be careful about like what structures. The other major milestone is I actually got the wheels turning last night because I have all the motor controllers hooked up. I am so sick of wiring. Oh my God, all the wiring, all the time. I actually had a lot of wiring to do because 6 motors, because I'm using encoders, I'm using the same motors that Marco's using on his. That means 6 motors, 6 wires each, power and ground for each one, and then 4 wires for quadrature encoders. So a lot of tiny little wires. I'm going to have a blog post or maybe even like a meeting. I'll do a presentation at a future meeting about like cable management and wiring and everything, because I've done this like on my own robot here, and I've also been like paid twice now to help people with their wiring harnesses. So this is just getting to me. Also coming from my background as a sysadmin with having to route cables and network cables and stuff like that, wiring is totally a thing. So that's, it's actually moving, and the motors are turning, and I'm actually hoping to be able to have it drive around at the next meeting in October. So progress is being made. Oh, and it has a Hackaday page. I was like one of the featured projects on Hackaday this week. So go check that out. I'll post a link to the list.
Is this design similar to Marcos' design?
Yeah. This is basically this is my version of Marco's and Roger Mandam's thing. So kind of my own take, and there's actually probably about like almost, this is actually like really taking off as a project. There's almost like a dozen of these things out there now, different people doing different versions. Some are making them out of wood, some are making them totally out of metal. There's some guys that are using pneumatic tires for theirs as opposed to 3D printing the tires. Somebody's using like the rim, and then they printed the treads in TPU, so in a flexible filament over top of a hub. This is actually turning into a really cool project.
Post information to the group.
Yeah.
Yeah, thanks. Okay, I think, is there anybody else? All right, so we got the best for last year.
All right, so this is a project I've been working on called Door Butler. And ultimately what it is it has a facial recognition piece for basically recognizing someone's face and then learning their name. It asks you your name, you tell it, and it recognizes you next time. But ultimately, replace your peephole with the camera, and you'll have then a screen that will kind of be your new peephole. So you don't have to look at the views, have basically a screen for your peephole. But it also has a piece where it has like basically a chat bot, so it can start a conversation with you. So what I'll demonstrate here is we start it up. So first what it's going to do is it's going to try to recognize me. So I'll have it, I'll come stand over here. Here, so once it starts up. And it'll recognize me, then it'll greet me, and then it'll go into the chatbot phase where I can start asking questions and have a conversation. Yeah, it'll talk, it'll talk. It's like right in there. And so right now I have a Pi Zero with the AIY hat on it, and I also have a new Raspberry Pi 4. And They're basically communicating to each other using Google text-to-speech. We also have a hat for speech to text, text to speech. And then I'm using Tesseract and for doing some also some text recognition. Let's see here. And then I'm also using Spacey for kind of a lexical analyzer to parse the words, the sentences, to get the name and make sense of the sentence. Should be starting up here in a second. Maybe it's because it's not power. Come on, baby. Still loading the encodings. Come on.
Is this your own design?
It's
Yes.
quantum computers.
Yeah. Go. Well, if anything, I can just load the piece inside the chatbot, which is kind of cool. So you can like talk to it and it talks about it. I should have just plugged the whole thing in. I just got a new battery. I should have tried it before I came here. I doesn't really like the battery, I don't think. Yeah, this is taking too long.
We'll test it in battle.
Yeah. Well, that doesn't seem to work. So what I'm going to do is, I'm just going to come back over here. Let's see, control stop that. Lost it. All right, so, let's see here, LS. What is it? SH. What's it called?
When I was working with this, my name's not a proper name.
All right, so this one's right.
And so
This right one.
it named me Fish. And then it named me Meadows. Sorry. So my new code name's Fish Meadows.
Okay. Microphones. Pretty good. How's your day? Well, that's good. What's your favorite song?
The humans are dead.
Or, Tyson Welliver, Welliver is the word. 4A, Tyson Welliver, bird, that's the word for. Tyson Welliver, bird, that's the word. So Welliver, Welliver is the word. Or, Tyson Welliver, bird,
Singing the song, I guess.
I think it's stuck. Not clear on the concept. Well, that's lovely.
Bird, that's the word, Welliver.
I didn't know you sang.
Learn something new.
I learn something new from you every day.
Even Christmas Day, it's good to meet someone who is losing.
No, I see.
So the Pi is actually running text-to-speech. It's quite interesting here, seeing what's going on behind the scenes.
Yes, I'm listening to you.
What's your favorite movie?
My favorite movie is Terminator.
Unfortunately, yes.
What did you think about it?
The robot scared me.
Tell me what you like about them.
They scared me. I was scared.
The freshman stare, the worst stare.
No, the robots.
So is this running like a ELIZA program?
No, it's using a,
$10 per visit.
it's a TensorFlow based.
Is it Google AIY?
No,
Okay.
no, not Google.
And it's all running on the
Well,
Pi?
Google, it is for the text, the speech to text. Yeah. Do you have anything interesting to say?
Will you try to stop people from fighting?
How about you try to do that?
Try my best at everything. That is all anyone can ask of someone.
That's good. Good advice.
Okay, well, good night. I have to go.
Yeah, okay. Well, that's okay. See you later.
Post the details on the web.
Oh, really?
On our Google group, if you
Okay.
have any information, like a web page or something that describes how it works. If not, make
I was going to try to make some money off of it, but you know. It's true. I can show you how I did it, just maybe not give all the secret stuff.
Sure.
Cool.
Yeah.
Thanks.
All right. Thanks very much. Okay, I think that was the last robot, or the last project.